keep a clean nose. Wash the plain clothes. You don't need a weatherman to know which way the wind blows.
You may not need a weatherman to tell you which way the wind is blowing on the ground right now, but if you want to know what the weather will be like tomorrow, knowing what the wind strength and direction is at different levels in the upper atmosphere can help predict if tomorrow will be a good day to go flying. The winds aloft drive the weather. The Miami office of the National Weather Service is one of about 90 locations in the U.S. that launch weather balloons twice a day to measure conditions in the upper atmosphere to help generate area weather forecasts. Is the atmosphere stable? Will there be lift? Will there be storms? Data from weather balloons is crucial to the forecast.
Yeah, so I'm a meteorologist at the National Weather Service Miami office, which the building is right behind me. And what we're doing right now is we're inflating the weather balloon because we launch 2 weather balloons per day. And we attach a meteorological instrument called a radiosonde that takes measurements as we let the balloon go through the atmosphere, and it takes measurements of the temperature, pressure, and humidity and winds. And there are about 80 different locations throughout the United States that launch weather balloons twice a day to gather this important weather data.
Do other parts of the world do the same thing?
Yes, and they all launch them like the same time. They're called synoptics. So it's at 12 Zulu and 0 Zulu time, which here is after 6 a.m. and 6 p.m. So we can't launch it before 6 p.m., but we can launch anytime between 6 p.m. and 7:30. And every location in the world is launching their weather balloons at the same time. So I'm happy that I don't live in California because, you know, I would have to launch weather balloons at 3 a.m. and 3 p.m. instead of 6 a.m. and 6 p.m.
Yeah, that 3 a.m. launch, I bet, is kind of tough.
Would be tough, exactly.
All right, very good. So where does the data go, and how soon does this data get incorporated into the forecasts?
Oh, well, as soon as we launch the balloon into the atmosphere, I will go back inside, and then the data, we have a computer where we have the data feed coming in immediately. Because there's a GPS on the radiosonde, and so that data gets transmitted back immediately into our computers. And then even before the balloon bursts, once the balloon is about a little bit less than 100,000 feet high, we get a complete profile, like in graphical format, of the temperature, humidity, and winds. And meteorologists call that a skew T, that profile in graphical format. And the gas has turned off. So
Okay.
I'm going to go in and turn off the hydrogen and turn off the power.
Okay.
And I'll be back out here in just a sec.
Okay.
And to get the excess hydrogen out of the line, just go like that. And you heard the
Vented.
a little bit of hydrogen there. And now I'll turn the power off over here. Okay. And now we're going to tie this rope around the balloon. So in the meantime, while I'm just tying this, do you have any other questions?
So I saw on that, like, is there any like human analysis of the data, or is it pretty much?
Yes, because sometimes there will be erroneous data or data that's a little bit unrepresentative. So humans can look at the data and edit it, and that will be my job. But most of the time, no editing, little to no editing is required. But if you see something where like the temperature suddenly decreases by 20 degrees in like 30 seconds, then that's kind of unrealistic, and we'll kind of smooth out that data over like over an 1,000-foot height.
So you're looking for temperature lapse rate. We talk about that when we fly,
yes,
as a way of determining whether the atmosphere is stable or unstable.
Exactly.
And we also, when we fly gliders, we're concerned with the temperature dew point spread because we want the cloud base to be as high as possible. So we like it when it gets pretty dry and the clouds don't start to form until about 5,000 feet here in Miami.
Right. And we also do the airport forecast for the South Florida airports. So VFR, visual flight rules, is when it's the sky is not is scattered or less, like, you know, the clouds are less than broken for below 3,000 feet, or the clouds are higher than 3,000.
So the flight service station doesn't do any of that. You guys prepare the terminal area forecast,
Right,
and
terminal area
and the METARs and all that stuff. Right. If I say METAR, you know.
Well, the METARs come in automatically.
Oh, right.
But we get all that data into our system.
Okay.
And, it gets disseminated to. There's a lot of people that that look at the weather for the airports. I mean, the people at the TRACON, the people in the tower, and at various regional airport centers and things like that. They're monitoring the weather all over.
So you guys do it for all the way up to the Tampa area, or?
We are basically from Lake Okeechobee southward. So
Okay.
Naples, Miami, Fort Lauderdale, West Palm Beach are
Okay.
the biggest
Very good.
cities. So now I'm gonna
So that's tied off, and
place this under here, and then I'm gonna tie the tongue of the balloon.
so that's not going to leak anymore. But you
No, 'cause
you don't want
if
it.
there's nothing coming out of here.
Right.
But just to make sure it's tight. Let's see if I can find that piece that I cut.
The arm's length piece.
Yeah, here it is. Let me close it up.
So you guys do this in the rain, just as long as it's not lightning? Is that what I heard?
We don't release lightning and thunder because it's for two reasons. One, because it's dangerous, and two, because if there's a thunderstorm, the conditions that the balloon measures will probably be unrepresentative of the larger scale area, because thunderstorms are short duration, and they'll have really strong updrafts and downdrafts, and the meteorological conditions right around a thunderstorm will not be like representative of a more longer time period or larger scale. And you have like one of these balloons like every 150 or 175 miles or so in the United States. There's one in Melbourne, one in Jacksonville, and one in Tampa and Key West. You know, so that's about this spacing. So it's really meant to just measure the synoptic, the large scale conditions.
Okay.
You know, not really a representative of like something that might change on a scale of a few miles, like a thunderstorm.
So I see you've got the mat grounded and all that stuff for no static discharge, and
Yeah.
very serious.
That's exactly.
We all saw the Hindenburg. We don't want that to happen.
Right, yeah. So there's never been an explosion at a National Weather Service upper air inflation shelter, but knock on wood, right? Like
You don't want to be the
if
one.
you wanted to do it, you could, you know, light a cigarette right in as someone's like filling up hydrogen, or like try to, yeah, that would be really bad.
Okay.
So now I'm pretty much done inflating
Okay.
the balloon, so I'm gonna go inside for 15 minutes and get the computer started up, and then I'm gonna be back out here with the radios on.
Okay.
And it'll only take me a couple minutes to attach the radios on before we let the balloon go. A lot of tape comes on these radiosondes. We'll open the program. Now this is the GPS receiver. This is the GPS down here. This is the temperature sensor and the humidity. And take the coverings off those guys. One more piece of tape. Okay, and the reason we're pointing the temperature and humidity and GPS at different angles is so that they don't interfere with each other. They stay sufficiently far enough away. This is for the frequency, which I'll just set to the default frequency. And now we connect the battery. The red and the white I need to connect together. So connecting the battery will enable the data from the radiosonde to be received by the computer. Well, first it goes to the satellite and then back down to the computer. Okay. So now it is time to create a new flight, file new flight. And this is going to be the 95th flight of 2018 so far. So 095. Release number 1. Probably about 95% of the time everything goes fine with the flights, but every once in a while we'll have something go wrong, like either a bad signal or even after we release it, and if there's bad weather going on, then then we have to do a second release and get a new balloon ready, but hopefully everything goes well this time. So this is release number 1 for flight number 95, my initials, and the date and time. 217. Now, there aren't very many clouds outside. Steven, what do you have? Few in the taps? Like, I forgot to look at the sky, to be honest with you.
You have 4,000.
Few. That's the METAR or the TA?
METAR.
METAR, okay. Yeah, it's probably not much. I'm just gonna put clear. I'll put 1/8. 1. Right to the cloud base. 9. So that is the cloud code, like basically how many eighths of the sky is covered by clouds, what type of low and mid-level clouds, and the height of the cloud base, but there's not very many clouds outside. So present weather, with fair weather like this, we usually go with state of the sky is unchanged and everything else is good. So now fill in the surface data and we'll look at the monitor over there. Barometric pressure, 1,021 millibars. Oh, it just changed a little bit. 20. Dry bulb, 25.1 degrees Celsius. Relative humidity, 66%. Wind direction is 146, which is southeast at 5 knots. Now we're running a couple of minutes early, so we have a couple of minutes to spare. But we're pretty much ready to press OK now. But I'm going to wait for two more minutes to do that until 53 minutes after the hour. In the meantime, most of the sondes burst and crash over either the Atlantic or the Everglades. But just in case they recover, we write the date and also the office. MFL is the Miami office. All right, we're going to press OK now, and we'll be able to see if the signal of this sonde, of this radiosonde, is good. So basically I'm waiting for all green check marks on this computer. It takes a little over a minute after I just clicked OK there to get all these green check marks. They're basic. They say like radiosonde signal, GPS, temperature, humidity sensors, just to make sure that everything is ready. And once you see all those green check marks there, we'll start seeing these values come in, like pressure 1021, temperature, humidity. Now, of course, these temperature and humidity values are the values that are inside the building, but as soon as we take it outside, they'll be the values from outside. And the system automatically detects once we release the balloon, because once it starts gaining height after I let the balloon go, then the system detects that I've launched the balloon. And that's really where the sounding begins. I'm just checking these numbers to make sure everything looks okay. Yeah, the height looks good. The signal strength of the radiosonde looks good. And all these other readings look good as well. So now we just wait until 55 after the hour, which is 1 more minute, and I will call the MIA airport tower, because we're located about 5 miles from the Miami International Airport. If a weather office that's releasing a balloon is located less than 5 miles from an airport, or 5 miles or less, they're required to call the airport tower to let them know that they're about to launch a weather balloon. And we're located just over 5 miles, about 5.2, 5.3 miles, but still we call them as a courtesy because we're right on that borderline. And so I'll call them and tell them balloon release in 5 minutes, and then I'll hit the arm button, and then we'll go outside. Hi, this is the National Weather Service. We have a balloon release in 5 minutes.
All right, thank you.
All right, have a nice evening. Bye. All right. I'll call you in a few minutes, Stephen. All right, we're going outside. All I have to do now is tie this around here with 3 knots, and then I'm just going to call back inside to my colleague Stephen to make sure that the signal is still good on the computer before I grab the balloon and release it.
So I'm just going to get a close-up view of what it says on the box.
Oh yeah, sure.
Yeah. Okay.
Well, that one I had to rip off some tape. So
Okay.
that's harmless weather instrument. So everything is completely biodegradable, so it doesn't harm the environment.
Great.
That's 1 knot.
And the little cup thing on the end, that's part of one of the sampling devices?
Yeah, so this is for the humidity,
Okay.
and I already explained those things on the other video. This is the temperature sensor. This
Okay.
is the GPS.
Okay. That looks like a J-pole antenna. Doesn't need a ground plane.
And that is 3. So the next thing I have to do is I have to walk over here. I'm going to place this on the hooks, and then I'm going to use my cell phone to call inside. This happens to be where we get a good signal from.
Okay. And that's an official National Weather Service pole there with the sun on it?
I guess so.
with a happy sun.
I think it's just a pole. So now I'm going to call Stephen and ask him to make sure that the signal everything is still green and ready to go. Here we go. Hey, it's Andrew. How's everything looking? All right, thanks. Okay, and now it's 6 o'clock, so so now we can release it, because 5:59, 59 seconds, too early to release. But now that it's 6 o'clock, we can release the balloon. And we also want to check for planes. So the last thing I did inside before I came out here was I called the MIA airport tower to let them know we're releasing a balloon in 5 minutes. And so now we will release the balloon. We're about 30 seconds away.
30 seconds and counting.
So one of the things that is to make sure that when I take the balloon out, that it doesn't hit the roof or the sides of the building, because it does, it'll probably go pop. Oh, you want to help me there with that little blade of grass? Thank you. Oh no, the others are fine.
Okay.
Thanks. So, I think we're good with the planes. And you may, just in case it's going to go due west after or it's going to go probably that way. So I'm going to stand a little farther over here so it doesn't hit the top of that building.
Okay.
Here we go.
Here we go.
5, 4, 3, 2, 1. Let go of the balloon. Wow, that was a close call.
Oh, I hope we weren't responsible for.
Yeah. Should have did even farther that way, but it didn't hit anything, so we're good.
Very good.
Okay. You can watch that.
For a minute.
I'm gonna go close up the shelter.
Looks like a good launch. And how fast does it go up?
It goes up at about 300 meters per minute, which
Okay.
is 300 meters per minute. Yeah, I guess you can do the conversions to miles per hour for that.
Okay. So, Andrew, tell me how you got into this, and when did you decide you wanted to become a meteorologist?
I decided I wanted to become a meteorologist when I was 6 years old, after Hurricane Andrew destroyed my neighborhood.
Wow.
I grew up in Kendall, in southern part of Miami-Dade County.
Yeah, that was a pretty traumatic event for a lot of people.
My name was also Andrew, so I knew that forecasting was my real passion, and so I started applying for jobs in the National Weather Service and in the private sector to forecast the weather. And eventually I took a job in Houston, Texas with a company called Storm Geo, and I worked for them for 4 years, from 2012 to 2016, and then I joined the National Weather Service here in Miami, which is also my hometown. So lucky me, in 2016.
Is it standard, generally everybody, let's say that you work with, they all go through, let's say, a degree in meteorology, as opposed to, let's say, other computer sciences or earth sciences? Or are there any other like fields you'd say it's just really, if you're going to be a meteorologist, you study meteorology?
Yeah, I'd say in our building there are probably a few computer people that might not have a degree in meteorology, but are really good at IT and other computer programming and things of that sort. But I think the majority of them have a degree, more than the majority, probably over 90% of them have a degree in meteorology. Now, as far as the meteorologists here, there's a very healthy mix between meteorologists that have a PhD or a master's or just a bachelor's in meteorology. Most of the senior hurricane forecasters, they either have a PhD or a master's.
Okay. So you were saying, I just want to kind of go through again that you do the aviation forecasts. And so that, the people watching my YouTube channel are a lot of pilots. And so that's an ongoing thing. I guess you're issuing TAFs a couple times a day? Or
my office issues TAFs, terminal aerodrome forecasts, every 6 hours. And then every 3 hours we do an amendment. Or we can amend the TAF as needed if the weather somehow gets a lot worse. And we do that for 7 airports in South Florida. Miami, the Fort Lauderdale, West Palm Beach, and Naples. And also we do Fort Lauderdale Executive Airport, Tamiami Airport, and Opa-laka Airport.
Not Homestead
We don't
Air
do
Reserve.
that one. So,
Okay.
So
The military does
the
it?
military bases, I think they have meteorologists on site that are military meteorologists that do that for them.
Very good, very good. Well, I want to thank you for talking with us, and very interesting, and I'm glad that the balloon's launch was successful, because
Yeah, now
I
you
didn't.
can't see it anymore. Now it's been,
It's way up there, and it flies for like 90 minutes.
Yeah, 90 or 100 minutes, and so now once we're done, I'm going to go back inside and monitor all the data to make sure everything looks good.
Very good. Thanks again, Andrew. Take care.